This is problem number 10 from the H8-9 homework. Given the polynomial x to the fourth minus 2x to the third plus 3x squared minus 2x plus 2 has a root of I, find all roots. All right, with this one here, okay, we've got this polynomial to start out here, and all they're giving us here is that one of our roots is I. Now we know that if I is a root, we're also going to have a negative I as a root. So most of the time here, what we'll do then is we'll say, all right, well, what are the possible integral roots? We'd take this and say our possible integral roots. All right, would be positive or negative 1 and positive or negative 2. And then we'd have to get on and check that out here. So let me bring up my graphing calculator here for a second. I'll just move it over. All right, so if I go in here, right, and I say, x to the fourth, and then we have minus 2x to the third. Then we've got plus 3x squared minus 2x plus 2. And then we graph it here. You're going to see a graph here, but notice here, this graph, right, if we look at negative 1 and negative 2, positive 1 and positive 2, right, it doesn't actually touch the x-axis at those points. So there are no integral roots here. Okay, so we're going to have to look at what are we going to have to do here. So there are no integral roots, but we still can solve this. So we're going to take this here, and I'm going to have you do synthetic division using the i's. Okay, so this is probably the first time I've asked you to do this, so this one's probably pretty tough for some of you. Okay, so since I know I is one of my roots, I'm going to take my I, I'm going to put it up here, and then I'm going to write out my coefficients. I'm going to put 1, negative 2, 3, negative 2, and then positive 2. And you may want to give yourself plenty of space there between them because some of you like to write pretty small and it may get a little tight there. Let me fix that. That's better. All right, so we'll bring down our 1. Now 1 times I is just I. When I add negative 2 plus I get negative 2 plus I, right? I can't really combine those together. Now when I multiply negative 2 plus I times this I up here, negative 2 times I is negative 2I. And then I times I is I squared, which is just like a negative 1. So we have negative 2I minus 1. When we add our 3 and our negative 2I minus 1, we're going to get a negative 2I, and then 3 plus negative 1 is going to be plus 2. And now we have negative 2I plus 2 times I. Well, negative 2I times an I would be negative 2I squared, which is going to make that a positive 2. And then we'd have positive 2 times the I be plus 2I. Now we're going to add again. Negative 2 plus 2 is going to be 0, so we're left with just a 2I in that case. And now we're going to do 2I times I. We're going to get 2I squared. Remember, 2I squared is going to be negative 2. So when we add those there, right, we get a 0 there. So I obviously, is a root there, and, that'd be like x minus I is our factor. Okay, so let's take it now here, right? We do have a second root that we know, that negative I. And let's do the same thing, just like we've done on some of the problems already here. We divided it by each of the factors one at a time. So now I'm going to bring down the 1, the negative 2 plus I, the negative 2I plus 2, and the 2I. And we're going to do our synthetic division again. So bring down our 1 times negative I is a negative I. When we add negative 2 plus I plus a negative I, we're going to get negative 2. Negative 2 times negative I is going to be positive 2I. Look what happens here, right? Our i's cancel again. Now we have just positive 2. And then 2 times negative I is going to be a negative 2I. And when we add those together, we get 0 for the remainder. So what we've done so far here, if you're keeping track, putting it together, we have x to the fourth minus 2x to the third plus 3x squared minus 2x plus 2, right? We've factored this into an x minus I times an x plus I times an x squared minus 2x plus 2. All right, so now that everything is just linear and quadratic, we can solve it to find the other roots, right? We already know that this is x equals I, and this one is x equals negative I. Now, x squared minus 2x plus 2, we know it's going to give us imaginary numbers because we had no x-intercepts when we looked at the graph. So what we're going to do here then is we're going to solve that now, right? So I'm going to say 0 equals x squared minus 2x plus 2. We'll take it and do our quadratic formula, right? So a is equal to 1, b is negative 2, and c is positive 2. So the opposite of negative 2, plus or minus the square root of a negative 2 squared minus 4 times 1 times 2, all over 2 times 1. And let's just get to simplifying here. We've got x is going to equal 2 plus or minus. Inside of here, we should have a 4 minus 8, which would be negative 4. So we have the square root of negative 4 all over 2, which should be 2 plus or minus a 2i all over 2, which then should get us 1 plus or minus I. So we just pulled out 2 more answers here, right? There's 2 roots, and then here's our other 2 roots. So our overall answers for this one here, right, there should be 4 complex roots. X is going to equal, we already had, our I, our negative I. Now we've got 1 plus I and 1 minus I. There are the 4 roots that we would have. Because remember, it's a degree of 4, so there should be 4 solutions. All right. Now, is that the only way to do this one? No, but I think that was, hopefully you should understand that we can do our synthetic division with the i's, just as long as it follows the same rule as what we've been doing. If it was just, x minus r, and in this case it was. All right. Problem number 10 from the H8-9 homework. If you have additional questions, please make sure you reach out to me. Thanks for watching.